So today we'll be going through the first three problems of AIME I 2019. Consider the integer n, which is 9 plus 99 plus 999 plus 9999 all the way to 9999999 with 321 digits. Find the sum of the digits of n. Solution. So n can be rewritten as 10 minus 1 plus 100 minus 1 plus 1000 minus 1 all the way to 10 to the power of 321 minus 1, which is 1111110 with 321 ones minus 321. Now we need to look how the last three digits of the number change when 321 is subtracted. So 11,110 minus 321 is 10,789. So n is 1111110,789 with 318 ones. Hence the sum of the digits of n is 318 plus 7 plus 8 plus 9, which is 342. Jen randomly chooses a number j from 1, 2, 3 all the way to 20. Bella then chooses a number b from 1, 2, 3 all the way to 20, distinct from j. The value of b minus j is at least 2, with a probability that can be expressed as m divided by n, where m and n are relatively prime integers. Find the value of m plus n. Solution. From the similarity of the problem, the probability that b minus j is less than 0 is the probability that b minus j is greater than 0. And since b minus j cannot be 0 since b and j are distinct, the probability that b minus j is less than 0 is a half. Now we need to find the probability that b minus j is 1. For each value of b, from 2 to 20 inclusive, there is one value of j that gives b minus j is 1, namely b minus 1. For b equals 1, there are no such values of j. So we have 19 values of b and j that give b minus j is 1, and 20 multiplied by 19, which is 380 possible values of b and j. Hence we have a probability of 19 over 380, which is a 20th, that b minus j is 1. So the probability that b minus j is less than 2 is a half plus 1 over 20, which is 11 over 20. So the probability that b minus j is at least 2 is 1 minus 11 over 20, which is 9 over 20, and so m plus n is 29. Finally, we have problem number 3. In triangle PQR, PR is 15, QR is 20, PQ is 25. Points A and B lie on PQ, C and D lie on QR, and points E and F lie on PR, with PA equals QB equals QC equals RD equals RE equals PF equals 5. Find the area of the hexagon ABCDEF. Solution. So first off, we have PR, RQ, PQ, which are 15, 20 and 25, which is a 3 to 4 to 5 ratio. Hence, it is a right-angled triangle with angle R being 90 degrees. The area of ABCDEF is the area of the triangle PQR minus the areas of the triangles APF, BQC, and ERD. So we will find the areas of all these triangles and subtract them from 150, which is the area of the big triangle. Consider triangle BQC. The length of its altitude from B is 15 over 5, which is 3, since BQ is 25 divided by 5, and as you can see, if we have B prime being the foot of altitude, B prime Q is similar to PQR, and it is 5 times smaller. Hence its area is 5 multiplied by 3 multiplied by a half, which is 15 over 2. Now we repeat the process with the triangle APF. The length of its altitude from A is 4, and so its area is 4 multiplied by 5 multiplied by a half, which is 10. We're just using area equals half base times height to find the areas of these triangles. Finally, the area of triangle ERD is simply 5 multiplied by 5 multiplied by a half, which is 25 over 2. And so the area of ABCDEF is 150 minus 10 minus 15 over 2 minus 25 over 2, which is 120. Thank you for watching. Please leave a like if you enjoyed this video, and feel free to drop a comment in the comments down below. Goodbye.